Okay, so guys, let's start with the very first question of the essay. That is to sum. I'm going to summarize this video within 5 minutes so that you can see the quick revision of that question. And all my upcoming videos will be only 5 minutes each, so you need not to watch long videos. And if are not able to understand in this video, just comment it down. I will re-upload that video for you. Thank you. So first we're gonna start with the first question, that is to sum. First I'm gonna explain you what the question means. Let's start with the example. For example, we have given an array that is 2, 7, 11, and 15, and you need to find the sum of two numbers that is equal to the target, that is 9. For example, uh, the index 0, that is 2, number 2, and the index 1, that is 7. The sum of these two numbers are forming 9. So we're going to find the index of these two numbers. So let's start with the very root solution of this problem. So guys, this is the root solution. If you are wondering what is root solution is the first solution and the and not so optimal solution that comes to your mind. Okay, so for a root solution, we're going to use two loops, that is for I equal to 0 and I less than n, and the second loop, that is j starting with I plus 1. Why we're gonna start with I plus 1? Because we need not to check the same number again, that is I. Okay, so that's why we are using I plus 1. And then we will simply just add these numbers, and if they are equal to the target, then we will simply return its index. Okay, and if we are not able to find such two numbers, then we will simply return a empty array. Okay, so this is the root solution. So now we're going to see the optimal solution of that problem. Before moving to the root solutions, let's see its complexity. Its complexity is very high. It is omega n square. Why it is n square? Because it is using two loops, and space complexity is omega 1. Okay, so before moving to the optimal solution, you first need to understand unordered map. Okay, guys. So, what is unordered map? Unordered map is like a dictionary or a phone book where key is the thing you search for, value is the information stored in that key. Let's see with an example. Like you're having a dictionary that is marks. I'm calling unordered map as dictionary. Okay, so marks of student Shreya is 95. So what is key here? Key is Shreya and its value is 95. Okay, so and marks of Rahul is 88. So this is unordered map. Okay, so if I go, so it's basic, or you can say basic code is counting frequency. For example, you have declared an unordered map. This is the declaration of unordered map. You can give any name to that unordered map, and for each value of x, that is we are iterating through the array ARR, and for each value of x we are just increasing its frequency. That's it. Okay, so let's look at for commands of unordered map. So this is the declaration of unordered map. For inserting and update, you can do like that. Just use its index. And for accessing a value, you had to do simply like that. Or for as if I told you from the previous example, if you want to know the marks of Shreya, so you can simply write MP. In bracket, you have to write Shreya. And for increasing frequency, you are doing this. Check if a key exists. This is the code for this. That is mp don't find dot find one. One is what? One is the key here, not equal to mp dot end. Okay. For deleting a key, this is the syntax. And for size, this is the syntax mp dot size. If you have to check if map is empty, you need to do simply like that. If map dot empty, cout empty. And last important syntax is for traversing. So you just need to do auto iterate, and I iterated it to empty, that is the unordered map. And you just simply had, if you have to print the key, then you just need to do it dot first, that is id dot first, and for the value you need to do id dot second. If you want to clear the map, then this is the syntax. Counter key, this is the syntax. That's it. Now let's move to the code. So this is the optimal code for twosome. Here what we are doing is we are simply declared an unordered map with empty. Okay, so we are using only one loop here. Okay, that is I equal to 0, I less than nums dot size, and we are taking a identifier, that is complement, that will be the minus of target minus nums of I. Okay, so let's say our target is 9 and nums of I is 2. So what will be the complement? 7. Now in the map we need to find if that complement, that is if 7 exists in that map or not. Okay, so we will finding by using this syntax, that is mp dot find complement not equal to mp dot add. Okay, so if we are able to find it, so we will simply return the index of that complement and the index that we are currently, that is I. Okay, so in this way we are able to find the twosome, and if we are not able to find at one iteration, then we will simply update nums of I to I. What is nums of I here? That is the key, and what is I here? That is the value. Okay, so in this manner we will be able to find the twosome. So this is the example. Let's say at one iteration at I equal to 0, what is num set I? That is 2. Complement of this is 7. Hash before map before, that is this. Okay, and at first iteration 7 will be not found, so we will simply store the 0 at the key 2. Okay, at second iteration, that is I equal to 1, nums of I will be 7, complement is 2, and hash map before, I mean what will be the map after first iteration, that is at 2 we have the value 0, that is index, and 2 will be found. So after finding, if we have found the number, then we will simply return the indexes. That's it. Thank you. That's all for this video.